Hello, everyone. So welcome to this Emergent session of the Open Science Room of OHBM 2020. So we all here together to talk about, well, I think the topic was very, like the title of the session is just pretty straightforward. It's going to be pre-registration and registered reports. So in case you don't know me and if you've never seen me, I am Rémi. I am Rémi Go. I'm a postdoc in Belgium at the University Catholique de Louvain. And I'll be sort of moderating this session. And the idea for this session sort of came from several things. So pre-registration has been around for a little while. So pre-registration, in case you don't know what it is just the idea that you are you're going to, before you run a study or before you run analysis, you're going to sort of write down what you're planning to do and you try to stick to that. And if you deviate from that, you also try to sort of say it. And the idea has been around for a while in different fields and either medical research or more recently has been adopted, starting to be more adopted a bit more widely in psychological science, for example. And this year, the NARPS project came out in neuroimaging, which is this project where the same team where different team were giving the same data set and had to analyze it in different ways. And just to see the variability you would get between teams on the same data set. And one of the recommendations from this paper was that maybe we should start doing pre-registration more often. Because this could be a way to reduce researchers' degrees of freedom, meaning that you could reduce variability between studies, for example. And as I was saying, in psychology as like psychological science is starting adopting pre-registration a bit more. And I think it would be a good idea to sort of discuss maybe what our lessons can be learned from psychological science about pre-registration so that we don't have to go through the same mistakes or have the same discussions that people in the field over there have already had. Another reason why I wanted to get these people together is that some of us here were involved in a hackathon at SIPS last year, so the Society for the Improvement of Psychological Science, where we tried to start working on how to sort of create templates for pre-registration in either fMRI, MRI, or EEG research. So we started some discussions around this at the time, and we figured maybe it would be a good occasion to talk about this a bit more here. And then I think it's also good to have discussions about what pre-registration can and cannot do for you. I think maybe especially at the beginning when they came around, a lot of people maybe saw them like as a silver bullet that would solve like all the problems regarding p-hacking and such and issues like this. And maybe it's actually maybe a bit healthier to actually have like a critical discussions about pre-registrations, what we should expect from them, what we shouldn't, and so on. So the way I want to sort of run this session is the idea is like, first we're going to, each of us is going to introduce themselves. And then I will let Chris give us a very quick sort of like the elevator pitch version of a difference between a pre-registration and a registered report, because this is something you might hear a lot about. And I don't think that everyone knows the difference. So I just want to make that clear that they're not exactly the same thing. They're conceptually related, but it's important to see the difference. And then I think after that, I think I'm just going to sort of open the floor to pretty much just like freestyle type of discussions. We have some bullet points idea of thing we could touch upon, but I just want to sort of see how the discussion goes about some of the ideas that we had in the abstract for this session. Okay, so I'm going to just pretty much introduce myself. I'm Rémi, postdoc in University Catholique de Louvain. I do fMRI research, and I've done a little bit of pre-registration here and there, or reviewed one, like a pre-registered study, and that will be it for me. And I will just sort of point at people as they appear on my screen, because otherwise this is going to get very confusing. So Rotem, you want to go next?
Yeah, hey, I'm Rotem Botvinik-Nezer. I'm a postdoc at Dartmouth College, and I have some experience with pre-registration. I pre-registered an imaging study about 5 years ago, and some behavioral studies since.
Thank you. Chris?
I'm Chris Chambers, so I'm from Cardiff University, and I'm a registered reports editor at a number of journals.
Dustin?
Hi, I'm Dustin Murchevsky. I am a data scientist on the data science and sharing team at the National Institute of Mental Health here in Bethesda, Maryland, USA. I have some experience with pre-registration over the past couple of years, ranging from just a short exercise of registering a study on OSF to a formal pre-registration in the Royal Society of Open Science.
Okay, thank you. Olivia?
Hi, I'm Olivia. I'm a research scientist. I work at a research institute in Cyprus called RISE, and also at UCL in the UK. I guess my experience with pre-registration is direct experience is working on the NARPS project, being on one of the teams and doing a model-based fMRI analysis.
Cool. Johannes?
Hi, I'm Johannes. I'm a third-year PhD student at the Donders Institute in Nijmegen in the Netherlands. And I use EEG and fMRI to study decision-making and reinforcement learning. And so I've done pre-registration for like 4 or 5 years now, but mostly behavioral projects. So I also do EEG fMRI, but it's mostly old data, and I haven't done it for that. And together with Rémi and some other people, I've been working on templates for pre-registration and how to do that. We have also worked at this year's OHBM hackathon on a project for EEG and how to facilitate that. The links are on the GitHub issue for this event, and we can talk about it later a bit.
And Gustav?
Hello, I'm Gustav Nilsonne. I'm an assistant professor at the Karolinska Institute in Stockholm. I'm a neuroscientist with a medical background. I do mostly basic research, but I've done some clinical research as well. I've pre-registered my own work as far as possible since a few years, and reviewed a bunch of pre-registered work. And I was also chair of the committee for badges for open science practices, in which we had a lot of discussions about pre-registrations.
Cool. So now that we have a clear idea of who is who, I think I'm going to turn to Chris to give us sort of like a very quick idea of the difference between pre-registration and registered reports, sort of like in a nutshell, what it is about.
Thanks, Rémi. Yeah, okay. So how do these differ? So this is a very common source of confusion amongst researchers, not just in neuroimaging, but in fact in a lot of fields. Pre-registration is an old concept, which, as you said in your opening, is quite well cemented in clinical trials research. It's basically where you take some aspect of your study, whether it's the hypotheses, the rationale, the analysis plan, how you're going to interpret the data, some part or all of this, and you formally state or pre-specify what that's going to be in some kind of public space before you do the research. So it's a statement of intent, it's a plan. That's there's a very big circle of research that falls into that window. Registered reports are a version of this which involves peer review of the pre-registered protocol. So with registered reports, rather than just putting a protocol up on a repository like the OSF, researchers submit their protocol, a detailed protocol, to a journal before they do their research. This is reviewed according to specific criteria. And if the reviews are favorable following revision, then the journal issues what we call an in-principle acceptance, which is a guarantee to publish the final results regardless of outcome if the authors basically stick to their protocol. So the two key ingredients which make registered reports distinct from pre-registration is pre-study review before results are known and in-principle acceptance regardless of outcome. And together what that means is that you take the normal pre-registration approach and you address bias, so reporting bias, which can still, as we know, creep in to pre-registration when it's done in a normal situation on a repository or on a registry, as we know from clinical trials research, but also by accepting the article in advance, regardless of the results, we aim to tackle publication bias as well, which is something that normal pre-registration doesn't do. So that's in a nutshell how they differ. So it's essentially part of that universe, but involving peer review and pre-acceptance.
Okay, thank you. I think this is always a much needed clarification before we get started. Okay, so does anyone want to jump in on a specific issue, or should just like open with something? Anyone wants to go first? Nope. So I think that maybe one of the issues, because this is mostly around neuroimaging and EEG, I think maybe we could start with I mean, from my point of view, I tend to get the feeling that pre-registration have been not really as quickly adopted in those fields as they might have in behavioral psychology or in general. I'm just sort of curious about why that is. I'm wondering whether this is just because we have so many more parameters, or that to sort of just pre-specify if you wanted to do a pre-registration, or if it's more, it has more to do with because some of the experiments we run are so costly that we cannot really just afford to just not publish something out of this. I'm just wondering whether you have any thoughts on this or in any other topic. I'm just throwing that in just to get us started.
I think that all the points that you raised are correct, but I think if I'm trying to look at what is different in MRI or EEG, my experience with MRI, with regard to pre-registration and registered reports compared to behavioral studies is, first of all, there are many more parameters, and it's a lot harder to actually write everything and think about everything in advance. Another thing that I noticed, and it's also different from, you mentioned NARPs before, and it's also different from NARPs, is that in MRI, usually when you pre-register, it's going to take a few years to collect the data and actually get to the point when you analyze. And many things change during this time. So I think in any pre-registration, you usually go through some changes and then you need to explain and be transparent about them. But in imaging, it's even more because so many things change in 4 years, right? Or 3 years or whatever it takes you to collect a big sample. So unlike behavioral studies, which you may be able to complete in a few months or weeks, or depending on the specific, maybe not, maybe it will take 3 years as well, but usually neuroimaging takes longer, at least from my experience. So I think some people think that this is one of the challenges, that no matter what they will write now, even if they will think of all the parameters, the softwares will change, the versions will change, the threshold, the defaults, everything is going to change. And then what sense does it make? Why should I now sit and write? Of course, I'm not agreeing with this point of view, but I think this is one of the challenges that we may think about. And in ARPS, you didn't get, you actually got the data and you had 3 months to analyze it. So I don't think you face this specific challenge. I think this is one important point.
Can I add? So I think it also often requires a lot of experience. So I think it's kind of feasible for early career researchers, master students to acquire experience on analyzing reaction time data. But EEG and fMRI is just much more work. And I feel people often acquire expertise over a very long time frame. And at some point, they might be ready for pre-registration, but that takes a while. And in addition to also what Rotem said, many projects just have so many unknowns because you don't even know how people do the task, or what can go wrong. So what kind of reasons might be there that you exclude people? What problems might be there with the scanner, that you have artifacts and all those kind of things? So I think certain research projects are better suited for it, like direct replications, for example, where you know what can go wrong, where you know what you expect, where you know you would probably want to do the same pipeline as you did before for the first try. But it's just for other projects that are kind of the first of their kind, it's just very difficult, I think. And as I think so, it would be nice to have more structure in that. So for example, having a template or having kind of knowledge accumulating and then also being passed on by more experienced researchers to early career researchers. And this is something that we don't see yet, I think. There's no training on how to do pre-registrations.
I have something to add to this. I completely agree about the time frame that it takes to collect a neuroimaging experiment. And in the course of PhD project or something, that's like half of the students' tenure there or more. But I also think that the complexity of the data, it enables it to, so many different hypotheses can be addressed. And so people will collect a data set on a certain task, and then maybe a grad student will come in and be like, well, I'm interested in functional connectivity, so let's look at context-dependent functional connectivity. And so I think that why this hasn't happened is because there are so many ways to go about it. And so I think a beneficial point for this discussion is like, okay, how to pre-register. Well, a lot of times when we talk about pre-registration, register reports, it's like starting from scratch. Everything is an intellectual exercise and you writing everything out and then submitting it and then you collect the data. But a lot of times the data already exists. And so there are a lot of things that you can do with that. You can look at, you have sample size, maybe you have subject exclusion because of bad motion for something like that. But I think a lot of people are nervous to pre-register if they already have a certain thing that's already done. And so I think that that's worth talking about.
Yes, I'll jump in. I think you have an excellent point, Dustin, and I would like to try to phrase it a bit more formally and suggest that if we imagine a continuum between confirmatory and exploratory research, where on the one hand we have very clear hypotheses and we're trying to prove them or disprove them, and on the other hand we're just looking. I suspect that neuroimaging studies can occupy a larger part of this continuum at the same time compared to some other research designs. Because, well, partly because the hypotheses may have so many steps before they become operationalized. Like if we say that the insula is involved in interoceptive processing, there are very many decisions about what to do with the data before we reach something that impinges on our idea of that conclusion. And the other reason being that we collect so much stuff, and some of the experiments may be more confirmatory, and then other parts may be more exploratory in the same study.
Anyone wants to chime in on this?
So on that note, just getting everyone's opinion, because I don't know how I feel about this. In terms of pre-registering or even a formal registered report, let's say you come into a data set that has already been collected for a variety of reasons, and you want to do some analysis on. You haven't looked yet, but you know the structure of the data set. The data set's already collected. Would you want to like put up front that the data set was collected for other reasons and this is exploratory, and then you would want a confirmatory? Because I think a lot of people are really nervous about, I guess, putting that out there because of, and so like, yeah.
Wait, I'm just not sure I understand. Are you saying that we should be more explicit about like saying that we're doing reanalyzing a data set that already exists, for example?
Yes, and what has been done to it. I mean, obviously we should do that, but I think that that is one of the reasons this bullet of the discussion is why it hasn't been adopted further, is because I think people are nervous about, let's say, the same data set in a lab has been recycled multiple times for many different analyses, and kind of maybe destigmatizing that by adding some templates about how does this look. I think the NARPS project was really great for this, to start this discussion, or to keep it going.
I think, from what I remember, the issue has been sort of also, there's been an ongoing discussion recently, and even in just psychology, what do you do with like data set already out there and that you reanalyze, but meaning you're not you're not completely blind to the data, so it can be an issue, definitely. I was wondering if we had any news, because I think Chris, you were involved in this on NeuroImage was supposed to have an issue with registered reports, and how did it go so far, for example?
Yeah, so we've had we've given 13 in principal acceptances for various neuroimaging protocols through that special section, studies involving MEG, primarily fMRI, and a couple, in fact, across all the journals where I've edited neuroimaging studies, we get quite a lot of submissions where researchers are proposing reanalysis of existing data. It's very good, actually. I think it's a good way of using the data that we've got efficiently, provided we can control bias, which is, of course, one part of the assessment process. So, for example, at Cortex, you can submit a stage 1 registered report proposing reanalysis of an existing data set. All you need to do is confirm how much observation you've had of that data. And if the editors judge that there's too much observation, that you already know the results, then it's kind of a foregone conclusion, and pre-registration loses its value as an instrument of bias control. So the idea is, if you haven't seen the data at all, then it's automatically eligible as a normal registered report. If you've seen some of it, it becomes a judgment call of have you sufficiently observed the key variables that you already know the results. Okay, so it falls into that area of interpretation, and we ask reviewers to comment on that as well. And when these articles are eventually published, they're accompanied by a section in which the authors say, prior to performing this research or this reanalysis, this is the extent of the observation we had, just so that it's clear to the reader. But yeah, I've had good experiences overall. So the neuroimage special section was really good. We got lots of really great submissions, and most of them, I think 13 out of the 15 ended up getting in principal acceptance eventually. And there was a really wide variety of different kinds of paradigms and approaches and methods. So it was good.
Okay. We actually have some questions from the chat. One is by Antonio that says that if there are actually more parameters to think about and tweak, which could influence the results, isn't it actually more important to have a timestamp document with the pre-processing and analysis plans? Isn't it actually an argument in favor of that we have a more urgent need to actually sort of go for pre-registration in a field where we have so many possible things that we can knobs we can turn? I think that, yeah. Go for it.
Yeah, I just think that's a really good question. And one of the things I've realized editing registered reports now for 7 years is that the fields that need and will benefit the most from registered reports and the rigor of pre-registration are also sometimes the ones where it's hardest to get traction, because the field often relies upon bias in order to produce the kinds of results that are published in high impact journals. So the trick there is to make the pre-registration process actually work for the authors. So you make it advantageous for the authors to go down that track rather than it just being a chore or a bureaucratic exercise. And so I fully agree that where there is more demand for detailed specification, that's where the rubber really hits the road with pre-registration. That's where it's quite useful. But I would add one tiny coda to that, which is that you don't need to specify all the details necessarily in an analysis plan for a registered report. You can take a different approach using blinded analyses, where you say, we don't know what we're going to do with our data entirely. We're going to take this general approach, but we're going to use our data to guide us. But we're going to take additional steps to counteract bias in doing that by taking on a blinded analyst who will not know certain variables and will make sure that their own inspection of the data is independent of what we expect or predict to see in the data. And we've had some really interesting submissions going down that track as well, which is quite popular in other sciences, like in physics.
A bit like the approach of doing a cross-validation in machine learning. You have like almost like a separate data set, except that you have an analyst who's blind to the thing. Johannes?
Yeah, so I want to add 2 points to that. And one is also a bit more general about, I think, pre-registration. So one of the problems the pre-registration tries to address is, statistically speaking, overfitting. That you have conclusions and you have data that fit the conclusions, but it's really only this particular data. You've discarded certain subjects for certain reasons. You have adopted certain regressors in your GLM. You have decided upon certain timings, such that in the end, for these parameters, your conclusions are valid, but they might not be valid for the data you've discarded or other reasons. And there are possible ways to kind of validate that. For example, cross-validation, as you just said. So if you have a big enough data set, you can optimize your pipeline on a certain subdata set and then predict out of sample, do you predict also the test data set? So I think that there are other ways that people would, for example, use in more bigger data sets, but it's often difficult with small data sets. Or replication. So as you already said, so if you have one study and you optimize your pipeline for that study, then you replicate it again based on exactly the same pipeline. I think this is also something where you have more freedom upfront to optimize your pipeline, but then later on you have to stick to that. So I think there are like other ways to kind of prevent overfitting that are not pre-registration, but that allow for some more freedom upfront, and then you just have to collect more data, which often is more costly. That's the problem. And the second point is something that I also just saw there's a question popping up on that. One important point about pre-registration is also transparency. That often I think people had an idea when they started the project, and that has changed. And that's often not so clearly documented in the journals, also because the journals might not allow for it. And things change, like Rotem said. So the default for thresholding in FSL has changed from 2.3 to 3.1 in 2016. Those kind of things change. And I think it's often would be nice to report that down, to report the deviations from the original plan. And they often make total sense. If people would read them, they would say, yeah, that makes sense. Or like, it's good that you updated your plan. But it's often just not transparent because people actually didn't have a plan to start with, or they don't even notice their own deviations. Or it's not really clear because the journal has a certain page limit or something. So I think just having some plan at the beginning, and then there's just the template towards which you compare all your deviations is already nice, even if you change stuff. But I think people can then, readers and both reviewers and readers can make more informed decisions about what has changed. And I think that would be nice to kind of go on to Antonio's question, to just enhance transparency at least.
The question you were referring to is like the last one. So the idea, can we consider having live article papers and just pre-registration to allow for transparency in the whole life cycle of the process? I guess the idea here is that we have this very static papers or just a PDF and that don't evolve anymore, which also makes it very hard to sort of, if there is a new technique, we can't really update the paper or the conclusions because the thing is like, we see it as a set in stone. Whereas having something that's more flexible would allow for better transparency, I think. I think that was the point of the question. I'm tempted to go on a slightly of a bit of a tangent and to start touching on another issue, which is, I think, as Gustav, you said, there is this sort of continuum from exploratory to confirmatory research. I think another dimension in this is we have research that has theory that can be more or less strong, right? I don't think the two are orthogonal, but I think it's also interesting to think about where pre-registration can be the most useful, in which space there. If you have a very strong theory, do you actually need to pre-register? Or can you actually make like predictions that are strong enough that you can rely more on the theory than on having a pre-registration? I know there's been a lot of debate around this, and would be curious to hear what some of you have to say about this.
So just to be clear, I don't really analyze neuroimaging data, so I'm coming at this from a sort of like outside perspective, a cognitive science perspective, I would say. I think, I guess 2 points come to mind. One is that I think the exploratory, confirmatory distinction doesn't really make sense to me. I think there's something wrong with that in terms of how it allows us to understand the kind of experiments that we do. And so I'm happy to discuss it, but I'd like people to maybe first explain exactly how they see that before I say anything, because for me, the way I understand it, I don't really think it makes sense. Oh, and the other point is that I think the role of a supervening theory, so the role of creating theories in order to then go off and test them, or in order to use them to explain data and so on, can be seen as doing some of the work that pre-registration does if you do the theory properly, if you have a formalized and even computational theory. It can carry, it can do a lot of the heavy lifting that pre-registration kind of aims to do, but that doesn't mean they're mutually exclusive. They're completely mutually compatible. And theories do other things as well. So, I mean, the origin of pre-registration is in using it to constrain the clinical trials, you know, the many free parameters that they had in clinical trials, and the difference between clinical trials and other types of science. I mean, you could even argue clinical trials are not science, is that clinical trials don't have typically some ground overarching theory, but they just want to compare whatever 2 or 3 groups or whatever of patients in different conditions. And that's not really a substantive theory. It's more just a comparison of different things. It's very useful, and it leads to, you know, when done properly, leads to improving the way that we do, with the way that we practice medicine and so on. But it's not exactly the same as what you hope neuroscience, cognitive neuroscience, and so on tries to do, which is a much deeper understanding of the world, and hopefully the creation of sophisticated theoretical and modeling accounts, which is a completely different goal to medicine, which is, you know, helping people and improving people's health, obviously also great. So I think, yeah, those are the 2 things that I think of. So yeah, one is that kind of exploratory, confirmatory thing that I'd like other people to take up, and the other is that theories do more things, but can also very, very strongly constrain the way that we gather and interpret data, provided that you do the theories in a sort of open, transparent, and formal way.
Thank you for that clarification. I think it's really useful. Gustav, do you want to sort of elaborate maybe on the exploratory, confirmatory a little bit, so that maybe we can try to get on the same page here, or someone else wants to do it?
I'm not really sure what to. Okay, let me tell you about what happened the first time I tried to make a pre-registration of a neuroimaging study. I was a postdoc, and there were a bunch of professors in the team, and I thought we need to make a good plan and figure out what our hypotheses really are. And I wrote down some suggestions, and I put them on the table, and it turned out to be incredibly difficult to get any kind of thinking process going without actually having results to look at. But I kind of took a stick and beat this process to the point where we actually had directional hypotheses for the most important things we were looking at. But we had too little theory. I mean, the project was really exploratory for many of these hypotheses. And then when we had the results, I looked back at these hypotheses, and I realized I can't really defend how we arrived at a certain directional prediction after the fact. And that taught me that it's important to pre-register projects at the right level of confirmatory, exploratory status. Looking back at it, I think it would have been perfectly fine to just write, we are going to look at this and we don't know how it will turn out, but here's what we're going to do and how.
I think also with respect to theories, so I agree, Olivia, that they constrain some of your hypotheses or analysis, but theories are like, it's not clear sometimes if the theory was there before the data or after the data, right? And also in your own mind, I think, like for me, when I pre-registered, it was easy for me to see, like it took me about 3 years to get to the point when I actually analyzed the data and results. So I saw how my thoughts have changed since then. And if I would hypothesize now, maybe it would have been different. So I think also in theory, like sometimes they just change, either you read papers or hear about stuff, or your own data make you change. So I think this is why sometimes the timestamp hypothesis is actually important, even if you have a good theory. So we won't just say, yes, predicted. Right?
Yeah, I think it's important to remember the difference, or to think of the difference now between a theory and a hypothesis. right? So a theory typically does have many timestamps because they have already been published, right? So a lot of theoretical articles, whether they contain data or not, but articles that contain theoretical commitments or assumptions should be already out there in the literature. If you're proposing a completely radically new, different theory, that's usually really, really rare, especially in our fields. So normally theories do come with at least a year timestamp, and you'll have like the date of when it was whatever accepted at a journal. So I think that's important to bear in mind. The other thing that you're mentioning is when you have a very, very specific, like, Group A is going to do this, Group B is going to do that, a very specific hypothesis that obviously you can flip around if your results come out the other way. Yeah, obviously that is completely unacceptable. And I would even argue that is completely atheoretical, because you just flip that around without a theory, right? So it's important, I think, to remember that a fully formalized, published, whatever, peer-reviewed theory is embodied by many pre-existing journal articles. And for you to go off and do what I would call, I guess, hypothesis hacking, which is just changing your hypothesis at random, and or p-hacking, right, which we all know what it is. That is, borderline scientific misconduct, if not actually scientific misconduct. Whereas coming up with a new theory and publishing that, or depending on a pre-existing theory, is just actually doing science.
Can I maybe add to this? I think also with so there are some theories in cognitive science about how the mind does certain things, but in neuroscience we often we answer questions about localization or time, like which brain region encodes value or confidence or something, and or like at which time point in EEG do we see a difference between two conditions? And often we don't really have an hypothesis for that, but we just do a whole brain analysis. Yeah, so for example, for the NARPS project also, there were hypotheses about VMPFC encoding value, but people did a whole brain analysis. And for EEG, similarly, people often think that one component will show a difference, but they do cluster-based permutation tests over the whole time frame and a lot of electrodes and everything. So I think a lot of our research is quite exploratory, even if we specify hypothesis in the introduction, because we don't just extract bold signal from this one tiny region and then do a correlation or something, but we do a whole brain analysis. So I think there are theories in neuroscience that say region X does Y, but it's often, we don't even follow that so much, I think, because we often do a whole brain, because we're afraid we might miss something. Yeah, we think the ACC encodes value, then we look at the ACC, then we don't find it, so we think some other region might do it. And if you do it whole brain, then we see the VMPFC actually also encodes value. And then I think this is what often might happen, that we have an hypothesis, but another region also shows up in our analysis, then we report that one.
Yeah, I mean, I don't want to be like overly critical, but that's like a problem. Your field has a problem. I think it means that you have underdeveloped theories if the theory that you test is region A might be doing X, right? Because that's really, really weak as a theory. It doesn't really explain anything. It barely predicts anything, right? Because as you just said, if it doesn't do X, or if it does X, but you think, or maybe another part of the brain might also do that. I mean, that's completely unbounded, right?
Yeah, I think that's exactly the problem, that when you start thinking about those issues, you realize that the theories we have are in some fields or subfields are very, very weak, and that can be very frustrating when you start wanting to pre-register things. That becomes very striking. But it's not a new thing. I think Paul Meal and others have said that for a long, long time, but we tend to forget that. It's just that some of those debates just bring that back to them. To the surface again. We have some questions about what levels of details we should, for example, include in pre-registration or registered report. I think that one was partly for Chris, because he said you don't have to go into like the nitty-gritty details of everything, but some people say, well, actually, for some details might actually be more important to report because they might actually have an influence on what you get in the end. So where do we set the the threshold for this. And I think that also relates to maybe having how, if we want to create templates for this, how do we sort of prioritize which item in a template should be just, you know, at the top of the list and which should not, right? So maybe Chris, you want to comment on this?
Yeah, so it's a good question. I think more detail is always better in a registered report because it's just providing more information. So you know, one of the aims of registered reports is actually just to provide method sections that are repeatable. Because if you look at the literature, particularly in cognitive neuroscience over the last 10, 20 years, you find method sections are more kind of general descriptions of procedural norms rather than actual recipes for how to do an experiment. Compared to, say, if you went to a chemistry paper and you see step 1, step 2, step 3, step 4, this is how you get my result. So one of our aims with registered reports has been to build in that kind of reproducible detail into the methods, not just as a way of controlling bias, but also as a virtue of that, allowing other researchers to actually repeat the method. So more detail is always good. What I would say is where the detail is unknown and cannot be specified until you see the data, that's also a detail, right? So you can say we don't know how we're going to model this, or what parameter we're going to use there, or what filter we're going to use here, or whatever. But if the data looks like this, we'll do it this way. If it looks like that, we'll do it that way. If we absolutely have no idea whatsoever, we'll get a blinded analyst to come in and decide based on just looking at this bit of the data, and they'll make a decision without any knowledge of the rest of the data set or whatever. So there are always ways to control bias in the pre-registration context, whilst providing the maximum amount of information, I suppose, to your reader. Always thinking, I suppose, of your reader as someone who may want to repeat your experiment. I think that's the kind of general philosophy that we work with. And I'd also, I really agree a lot with what Olivia was saying earlier, just to go slightly back to that point, that in some ways, I think pre-registration is a bit of a crutch for weak theory in imaging, because as you said, Olivia, when the theory is unbounded, there is such an enormous parameter space that one can explore, which is fine if you're actually exploring that in a very transparent way. But of course, if you pick up a neuroimaging paper, it doesn't tell you all of the different routes that the authors tried. It tells you the one that worked. And so I do think there is a future here where theories are so precisely defined and so computational and so quantitative that in fact they dictate many of the methodological decisions that a researcher would make as they go through an experiment. And in that world, the value of pre-registration is much less, because you've used your theory to control your bias. And I think that's a nice future-oriented solution. And Olivia has a really nice paper on this that I think everyone in neuroimaging should read. It's I guess pitched toward cognitive scientists, but it's actually a very general message that it all begins with theory. And pre-registration is, I think, vital in neuroimaging now for one reason, because we lack that precision of theory. And so we use pre-registration as a way of imposing the rigor and the robustness and the bias control to produce valuable data that can maybe inform theory and help us build better theory in the future. But we're kind of in a catch-22, I think, with the standard approach.
Oh, thank you. I think there's a question about me saying that, implying that we shouldn't be doing, shouldn't be using these kind of unbounded methods of looking at neuroimaging data. Just to be clear, I think that the problem with not knowing things yet. So the question says, the problem is there's so much we don't know, e.g. looking at serotonin and SSRI, one of the common drugs used every day. We don't actually know what we're doing because we don't completely understand the serotonin system. So there's basic research in imaging where we simply don't know the theory. I think that's completely fine. Obviously, we don't know what's going on, and that's okay. But I think the way to move towards knowing what's going on, or the way to move towards having useful explanations, theories, anything that kind of helps us boil down the whatever, millions, billions of data points that we've collected in neuroimaging. Anything that helps us do that is a step in the right direction. And I think the only way to do that is to come up with theories and models and so on. And, you know, they're probably going to be all wrong. And that's fine. But the only way to move towards that is to create these theories and whatever, collect data that shows that, oh, you're completely wrong, and then try something else instead of just having a completely unbounded way of doing it. But even an unbounded way of doing it might be good if we transparently and openly acknowledge that that is what we're doing. So I think that's where pre-registration definitely comes in, when you have no other way of constraining the way that you're doing things, and you have no theory to fall back on, then pre-registration obviously can help. But I think that in an ideal world, I would really hope that people also think about having very strong theoretical commitments that, you know, that they can obviously say, I was completely wrong in their next paper, but at least be able to rule something out, right?
Go for it, Johannes.
Can I just two quick responses? So I fully agree with Olivia, and I think it's in the end again a transparency issue. So there's probably like a graveyard of dead theories that people know that they're wrong or that the data are not consistent with them, but we don't know about those dead theories because people don't specify them. So it's again, I think, more like a writing up issue or like a transparency issue often, that is also suboptimal with the current journal system, that people would need to have more space or be able to be more transparent with the theories that are actually considered, but they're not consistent with the data. I think that's, again, beyond pre-registration, another problem, transparency in theories and results. But to go back to Chris Chambers' point, of course, people, so I've heard this often, that people say the pre-registration should be as elaborate as possible, but then it becomes really hard to read for a reviewer or someone who wants to just have a quick look how the actual pre-registration looked like, because it's like 30 pages, 40 pages, just pre-registration. That's quite hardly usable. So for example, there are people like Simonsson who have created as predicted, but they say the pre-registration should fit on one page. Otherwise, it's just not usable for readers, which I think is quite the opposite extreme. But kind of if you have to prioritize things, so for example, I think subject exclusion is something really, really crucial, and people should be transparent about that, the exact reasons why they exclude subjects, which I think is more important than, or like also what they put in their GLM, which I think is more important than certain pre-processing steps. Because there are some things that might have less of an effect, whereas other things like that, how does a model look like, or which subjects do you include, which one do you exclude, they are quite important, I feel.
I agree with that. And I think what I've seen from neuroimaging authors for registered reports is they come up with creative ways to organize complex method sections in such a way that they're readable. For example, taking a whole lot of very dense detail, putting it in a supplement, but it's linked and it's part of the protocol. So you can structure a stage 1 registered report in such a way that it is still very coherent and very readable, whilst also providing all the information that is needed to limit bias and also ensure reproducibility. It's not impossible. It is challenging. I think it's challenging because we're not used to writing reproducible methods. We're used to writing methods which pass procedural norms. But it can be done, and I've been really impressed at how scientists have taken on this challenge and achieved it, actually.
I think I'd be curious to hear a bit more about maybe from Gustav, for example, on the badges thing, and also on how reviewers feel about, like, if anyone has feedback on how reviewers feel about going through like pre-registration. Whether we know how much they actually do it. Well, I guess obviously for registered reports they have to, but whether they feel it's like a painful experience, or is it something that they take on board very easily and so on.
Okay, I'll start with the second question, and I can answer this only from my personal experience. More detail helps, because then it's easier to see if the report and the pre-registration matches. Of course, if it's very long, then structure also helps, and standards where applicable. And I've seen some cases where people have a separate document of standard operating procedures, where they say that in our lab, we always do a certain transformation of a certain variable, for instance. and that's fine too. It can reduce the length. So I don't think it's necessary to keep pre-registrations brief just to make the reviewers happy, at least not from my own point of view. When it comes to the badges, you can find, I'll put a link in the chat for the criteria. What we tried to do there was to incentivize the best practices, which is to write, in our view, a description that is as complete as possible and that is crucially time-stamped before the intervention occurs in the experiment. Now, there may be, of course, value still in pre-registering even after some of the data are collected, even after some of the data are looked at, as long as that is transparent, but the best practice, nonetheless, is to do it first. Perhaps I can say something very briefly about a comparison to pre-registration of clinical trials at this point. So Chris mentioned that this has been going on for some time. The International Committee of Medical Journal Editors introduced a requirement back in the early 2000s, 2004 maybe, I'll have to check that. And this was not implemented very rapidly or very well by any of the participating journals. And it has been followed up many times by different meta-science groups. And the results almost invariably show that people switch outcomes and don't declare why, and so on, to a fairly large extent. So my expectation was that the pre-registration badge would lead to similar outcomes where people report that they have pre-registered their study, but the quality of the pre-registration may not be very good. And when that has been followed up, that has also been shown to be the case. So people make pre-registrations that are partial or that post-date data collection, or they have unmotivated, unreported deviations. That's all to be expected based on experience from clinical trials. But what we can do at least is to look at the pre-registration, and anyone who wants can see if the authors have done what they said they would. And so, for the authors at least, it's an instrument that they can use to prove to someone that they've not been fishing.
I think it sort of always goes back to sort of the idea that knowing whether pre-registration or registry report make a difference is itself an empirical question, right? Which is interesting to actually have data on. I think I'm not up to date on the latest, like people tallying what's going on. So if anyone has any, I think some people have looked into registry report, the effect they've had in psychological science, but I don't remember the numbers. I will not say anything.
Yeah, so the key difference with registered reports, of course, is that the reviewers look at it, whereas with the badges, in most cases, they are awarded based on what's called, the authors tick a box, and the reviewers don't check that it matches.
We have another question from Melanie Gans about actually going back to the NARPS project and whether should pre-registration go along with code sharing so that others could reproduce the results exactly. So if anyone just want to tackle that one.
Yes, that's an easy one, of course. What possible reason can there be not to share code unless it contains confidential information about patients or participants?
That was easy.
I think also there's like things like fMRI prep, like pipelines that get published in itself are also a way of standardizing or being more transparent. That you say you use this pipeline, this version on that day, and then you can say, but we changed this one thing about it. So kind of the idea of you can share the exact code, which is also possible with SPM or FSL or whatever, but you can also say we use exactly this standardized pipeline, this version, which I think already would help.
Yeah, on that note, I completely agree, and I'm trying to move in my own projects toward, well, our whole team is toward containerizing our entire pipeline, all of the dependencies, and putting our code up. That was the analysis, so that people could just download the machine that we use to process the data.
I'm scared to say something negative in case it's the last thing I say, but my experience, so I agree completely, obviously, always share your code, unless any of the caveats are met. But I think something very disappointing about code, I work on a bunch of journals, 2 journals that essentially publish code, one of which is called ReScience-C. And what we do there is we publish computational replication, so computational models that are already out there, and then people create their own version of the code. And what we noticed in many cases, and this is very disappointing, is that even 6 months later, the new, fresh, replicated code base might not be able to be run without any modification. So I guess my point here is that it's obviously great to share code, but I think we have to remember that sharing code quite often is not enough. You need to share like the specification or the meta description of the code as well, so other people can know when it doesn't work, what it should have been doing. So in some senses, code is really important, but we shouldn't assume that it can do the work that a specification, so a high-level description of what the code does, we shouldn't assume that code can play that role, unfortunately.
Yeah, I think one more thing is that they're both good practices and we need them. But I think one rabbit hole we didn't look at it, we didn't discuss today is the incentive part, right? Like, to some extent with the badges, but this is one of the main problems, right? What are the incentives for people to actually do it besides believing this is the correct way to do science, which is great, and we probably all think like this, but is it enough, right?
I think we are running close to sort of finishing, and I think I like 3 minutes. Thank you. I think Johannes' point might actually be a good one to maybe go for another like round. Everyone's opinion of what would be a next good step regarding pre-registration or some other possibilities to tackle some of the issues that pre-registration are supposed to address that we could take from now on to help. Not sure that was a very clear question, so maybe let me rephrase this. Like, if you had to take something away from this discussion of what you would like to implement, what would it be, for example? I don't like pointing fingers at people to say when they would. So, if anyone wants to go first,
I'll start. I think that's something that would be really great to implement, though this is kind of a very tough systemic thing to get started. But first year of grad school, just be a registered report pre-registration exercise. Get an account on OSF rather than just getting your hands on data really quickly and designing an experiment quickly. Just learn more about how science is done or should be done and put it out there as like the beginning of your science training.
go for it, Johannes.
I want to make basically the same point as Dustin, also as kind of the most early career in the round, I think. I think it's important to learn those kind of things. I think it's also a great opportunity to kind of go with the supervisor together over code and then see how do you actually do this in all of this. We discussed this last week actually in Journal Club at the Donders, and it's often quite hard also with registered reports because you have to be really, really specific and you need help for that, I think. So I think it's a great exercise and it teaches you a lot, but it also involves investment for more senior researchers that teach those things. And I think it would be nice in the future if there would be more training for this. So either requiring supervisors to be much more hands-on on this. So really telling them, I would analyze those data like this, and then you write it down. People learn much more, they find much more mistakes in their design and in their analysis code and so on. And then they run the study. Or having more systemic, also more teaching opportunities for this, like OHBM, more opportunities to discuss and kind of train people on how to do pre-registration for EG and FMI.
Anyone else want to have some sort of last final thoughts on this? Next step. I mean, I can give you mine, which would be I think 2 things. Yeah, maybe try to provide the community with some more precise templates definitely is the thing I think needed to sort of try to see what are, maybe go through, I think we have started doing this, going through the registration that already exists and see what are the most common items that are usually at the top of the list would be a good thing to do. And I do definitely agree with Olivia's point regarding theory. I think we need more formal training in our fields on what actually, maybe just, sometimes even just going back to philosophy of science and history of science, because there is, we're sometimes a bit just blind to where our field comes from, and we tend to forget this. And this is, this can be hugely useful in practice as well. I think we have to stop seeing those things as just purely just some like armchair way to kill time, just like where you just, it's not related to what you actually do. It's very, very important, I think. Anyone else? Or should those be the last words of this thing?
I guess just really quickly, if we have time, I just wanted to say thanks, and also that something that could be done is to think about how to formalize a pre-existing theory if you don't feel like you can come up with a new theory. So it can even be a theory you don't agree with, but you try to formalize it and show that it's, you know, whatever, appropriate or inappropriate given some data.
Okay, I think that we are out of time. So I will thank everyone. This was very interesting. I had tons of fun. I think it was a very useful conversation to have.